Hey guys, just wanted to take a look at the rest of the questions from worksheet 13. Let's take a look at number 2 first. Here, remember that all the radii in the circle are congruent. So because this radius is 8, this part of the diagram is 8 as well. And that's going to help us when we find x, which is just this outside part. Okay, remember that a radius drawn to a tangent segment is going to be perpendicular, and so then we know that this triangle is a right triangle, and it happens to be an 8, 15, 17 right triangle. This whole segment 17. So if this part is 8, then this part has to be 9, so because 8 plus 9 is 17. Okay, we did number 3 in the last video. Number 4 here, they tell us that the measure of arc UN is 147. Now notice, chord UN is congruent to chord SN, and if these two chords are congruent, then the arcs that they intercept must be congruent. So if UN is 147, then arc SN also must be 147. So we got those two, and then remember, all three of the arcs have to add to 360. So 360 minus those two 147s gets us the 66. And if this arc is 66, then the inscribed angle that eats that arc must be half of it. So then this angle is 33 degrees. Okay? We did number 5 in the last video. Number 6, the theorem here that you need to remember is that when you have an inscribed quadrilateral, all of the angles, the opposite angles are going to be supplementary. So z plus 6 and 2z minus 3 must add together to equal 180. So we can use that information to solve for z. Once you know what z is, then you can go and start your work on the other variables. So here, if we go back to the circle, these two opposite angles must also be supplementary, add to 180, but because they're different, adding them to 180 wouldn't really be helpful. We need more information. That other piece of information is that DB is a diameter. If we connect DB and it's a diameter, that means this is a semicircle. And this angle, angle A, is an inscribed angle that intercepts the semicircle. So that means this angle must be a right angle. So 3y equals 90. In the same way, we can look on the opposite, angle X inscribes a semicircle, so that means X should also be a 90-degree right angle. So a bunch of theorems here to use for number 6. Number 7, the theorems we wanted to use here was that when two inscribed angles intercept the same arc, those inscribed angles are congruent. So if you look at angle M, that eats arc NO. Same thing with angle L. Angle L eats arc NO. So since they intercept the same arc, angle L and angle M are going to be congruent. So that's where you get this 10x plus 10 equals 8x plus 16. And then the same with angle N and angle O. They intercept the same arc, but we don't, so we can set those equal to each other as well to get those values. But we already know what x is, so you can just plug in x to get all the rest of the measures that you need to know. Number 8, they give us the circumference is 38 pi, so the circumference is the diameter times pi, or 2 pi r if you'd prefer. Either way, the diameter is going to be 38, which means the radius is half of that, or 19. Once you know the radius, you can plug it into pi r squared to get the area. Okay. Number 9, we have an angle whose vertex is outside. So the angle whose vertex is outside is going to be 1/2 the big arc minus the little arc. And so you plug it in accordingly and solve. Remember the algebra here, we're going to multiply both sides by 2. 1/2 times 2 is 1, and what's inside the parentheses comes out untouched. Don't multiply 171 minus x by 2, because you already multiplied it by the 1/2, so don't do it twice. And then 2 times 43 does give you that 86, and then you can finish solving there. Number 10 is also an angle whose vertex is outside the circle, but this is our special case one. It kind of looks like an ice cream cone. When that's the case, when you have 2 tangent segments, instead of, you guys see over here, these were 2 secants. So we can't use that special case scenario here with number 9, but we can here with number 10 because these are tangents. And the relationship is that the angle and this little arc are supplementary. So they should add to 180. So you can find the measure of that arc that way. Number 12, another angle whose vertex is outside. So again, angle equals 1/2 the big arc minus the little arc, and solve that way. 11 and 13 we did on the last video. Number 14, another good one. Here we have a tangent and a secant. So it's going to be your tangent squared is equal to your secant. And it's actually the outside part times the whole of your secant. Remember that when you're finding your whole segment length for the secant, you're going to add those 2 parts together. So 24 plus 3 gives us that 27. When you solve, you're going to take the square root of both the x squared and the 81, and you get plus or minus 9. But again, in this case, x cannot be a negative, so we don't include -9 in our solution, only the positive 9. 15 and 16 are both super similar questions having to do with the template. So I really encourage you guys just to practice drawing the template. Draw a circle with your center, draw a chord going across the top, and then draw a perpendicular segment from the center to that chord. Okay, that's a great way to start out drawing your template, and then you can fill in accordingly. You do want to draw in that radius to close your circle. And then you just put the dimensions in as they describe them. So for number 15, it says the distance from the center to the chord is 30. That's this part right here. And then it says the diameter is 34. So if the diameter is 34, that means the radius is 17. Oh, I'm sorry. That was my bad. I read that wrong. Find the distance from the center to a chord. So they want us to find this distance, and they're saying that the chord is 30. So this whole chord is 30, which means that both of these segments are 15. So if you look at the right triangle, you have an X, a 15, and a 17. This is an 8, 15, 17 right triangle. Okay, same thing with number 16. Draw the template first and then label everything. They're saying that in number 16, the chord is 16 inches, which means both of these segments are going to be 8 because it's being bisected. The chord is 10 inches from the center. So this part right here is 10, and then they want us to find the radius. So this is Pythagorean theorem. This is not a 6, 8, 10 right triangle. Be really careful. In a 6, 8, 10 right triangle, the 10 must be the hypotenuse because the hypotenuse must be the longest side, right? In this triangle in our problem, the 10 is not the hypotenuse, it's one of the legs. So this is not a 6, 8, 10 right triangle. We actually have to do the Pythagorean theorem to solve for the hypotenuse. And you can leave it as a reduced radical or a decimal if it tells you to round it, but reduced radical is better. Okay, and then number 17, the area of a sector. So remember to find, it's like finding the area of the crust. You have to find the area of the whole slice of pizza and subtract the triangle first. So it's going to be angle over 360 times pi r squared minus 1/2 base times height. Or, as you see in this one, if our central angle is 60 degrees, that means it's an equilateral triangle. So you can use side squared root 3 over 4 instead, which is the one that we used here for the triangle since it's equilateral. And then you just simply subtract these two for your final answer. Don't try to combine them. Don't give me a decimal. Leave your answer just like this, where you have the area of the sector minus the area of the triangle. Okay? All right, guys, I hope that helps. Good luck studying and good luck on your test tomorrow.